Hey guys, so for this video we are going to learn how to calculate delta H using bond enthalpies. So bond enthalpy is how much energy it takes to break a bond. So this is actually number 48 on your homework. But we're going to work through this example together. So using bond enthalpy, so how much energy it would take to break a CH bond, that's single, right? This is how much energy it would take to break a triple carbon-carbon bond, right? So bond enthalpy, so it's always going to be endothermic or exothermic. It's always going to be endothermic, which means we're going to have a positive number. So it's always, let me readjust this here. It's always endothermic, right? Because you're breaking a bond, which means that you have to give it energy in order to break it, because there's an attraction here. So in order to break this bond, I have to give it energy, right, to zap those two apart. So always going to be endothermic. So that's one thing that we just learned. And it's going to be different for each thing, right? We learned in the other video that a carbon-carbon bond that's triple is going to be harder to break as opposed to a carbon single bond carbon bond, right? So these two are going to have different enthalpies. So in order to calculate this, what I'd do is I would make sure that I very clearly saw what was my reactants and my products, right? So let's go ahead and on each side list the type of bonds that we have. Over here, it looks like we have 2 of the C single bond H's, right? And it looks like we have 1 of the C triple bond C bonds. Okay? What else do we have on the reactant side? We have 2 of the HI bonds. So I haven't done a Lewis structure video yet, but you'll see that it's a single bond because it's H bound to I, right? So it's a single bond. So we have 2 of those, 2 of the HI bonds. Okay? Now on the right-hand side, what do we have? We have 2 of the CI bonds. We have 4 of the CH bonds. 1 here, 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 and here. So we have 4 of the CH bonds, right? And what else? Sneaky, sneaky, we have 1 single carbon bond. Okay, so we need to know which, we can total these up and that's all fine and good, but we need to know which side is going to be positive and which side is going to be negative. So it's the values that they give you are going to be endothermic, the given values. But on this side, I'm breaking bonds, so I have to give it energy. So this side is going to be positive. On this side, I'm making bonds. So I always like to go back to that example of having 2 magnets, and when you have 2 magnets and pink, they go together, right? You're creating a bond. You're creating this attraction, so they give off energy. So this side is going to be exothermic, so negative. So we need to keep in mind that you total up this side and it's going to be negative, and you total up this side and it's going to be positive. So we look at the assignment, which is number 48 on the homework, and I will pull it up. We're going to do this all together. So it looks like, and I'll do this side because I'm like right here, 2 times the CI, and it looks like the energy for CI is 240. Okay. 4 of the CH's, and it looks like CH is 413. And 1 of the C single bond C's is 348. So this is going to be my negative side, and my positive side is going to be 2 times the CH's, which is 2 times 348 Oh, sorry, that's 2 times 413. See, we all make mistakes. 2 times 413 for the CH bonds. We have a 1C triple bond C, which is going to be 839. Or, yep. And we also have 2 of the HI single bonds, which is 299. This is going to be my positive. So it's going to be essentially this side minus this side. So if you have to think of an equation for this, you could think of reactants minus products. Whoa, Carla, that sounds a little different. We usually do products minus reactants. This is the only time when we do not do that. It's because if you think about it, we have to break these bonds, so we have to give it energy. These bonds are created, so they give off energy, therefore positive, negative. So I'm doing this with you guys. Let's go ahead and total this up. I'm pulling up my little calculator. And 413 times 2, 826, plus 839, plus 598. Yeah, I can do math in my head. Minus 480 plus, and then I'm not even going to pretend to do 413 times 4 in my head, 1652 plus 348. And then remember, we need a parenthesis because this whole side's going to be negative, right? This whole side's going to be negative. So then I'm going to do 826 plus 839 plus 598 minus 480 minus 1652 minus 348. All that comes out to negative 217. Let's see if that is an answer option that we have for this problem. Negative 217, hit submit. We are correct. Okay, so that's how you calculate a bond enthalpy with given values. So that was number 48 on the homework. And if you're playing along with our game, you'll see that these numbers are listed and these numbers are given. The numbers that are given are always going to be endothermic because you have to break the bond, right? The left side, the reactants, is going to be broken, so you have to give it energy. The right side, the products, are created, so they will give off energy. Therefore, the left is going to be positive, the right is going to be negative. And then you just total them up. All right. Good luck, everybody.